Hi everyone. So finally we get to talk about how all of this stuff with long division, the division algorithm, and remainder theorem helps us to find zeros of polynomials. That's our goal, and we're finally putting it all together. So, how does this help us to find zeros? The factor theorem. This is the most important theorem for this section. What it says is if x minus c is a factor of the polynomial p of x, then c is a root, and vice versa. That means c is a root implies x minus c is a factor. So I want to show you the proof of this just to convince you that it's true. I won't test you on the proof, so if it just confuses you more, you can skip through this section, but make sure you watch the example at the end. So here's why we've got this theorem. Here's what's really going on. So by the division algorithm, we can write p of x as x minus c times something plus r. This r is just going to be a constant, so no x's, because its degree must be less than x minus c, than the degree of x minus c. And the degree of x minus c is 1. So the degree of r has to be 0, which means it's a constant. So then, if we plug in, so here's where the theorem comes in. So if x minus c is a factor, then we can write p of x equals x minus c times some q of x. It divides evenly with no remainder. So that when I plug in c, I get p of c equals c minus c times q of c. It doesn't matter what q of c is because c minus c is 0. So what this says is when you plug in c into the polynomial, it gets 0, so that says c is a root. And equivalently for our graphs, what this says is that c comma 0 is the x-intercept. So now we can look at the other direction of this proof. So if c is a root, this says that p of c equals 0, but by the division algorithm, p of c equals x minus c times q of c, or plus r. So in this case, we're not assuming x minus c is a factor. We're trying to show that it's a factor. And I plugged in c, so I don't have an x. I have c minus c. So this says p of c equals 0 plus r, but p of c is 0, so 0 equals r. 0 is the remainder, is what we just showed, which means that x minus c is a factor. So that's the proof of the theorem. Now for the important part, how we use it. What are the examples? So I want to use polynomial long division to determine whether whether negative 2 is a root of the polynomial x cubed minus 5x squared minus 9x plus 10. So if we look at the theorem again, what it says is if x minus c is a factor, then c is a root. So in other words, if the remainder when we divide by x minus c is 0, then c is a root. So we want to figure out if x minus -2 is a factor. It is if remainder of x cubed minus 5x squared minus 9x plus 10 divided by x minus -2 is 0. So if there's no remainder, then it's a factor. If it's a factor, then -2 is a root by the theorem. I'll say that one more time. If the remainder is 0, when we divide by x minus -2, that means that x minus -2 is a factor. By the factor theorem, if x minus -2 is a factor, then -2 is a root. So let's do the long division. X minus -2 is the same as x plus 2. So I'm going to divide by x plus 2. So my first step is how many times does x go into x cubed? It goes in x squared times because x squared times x is x cubed. So I take this, I multiply it by that, and I put the result underneath. The result is x cubed minus 2x squared, and I subtract. X cubed minus x cubed is 0. Negative 5x squared minus negative 2x squared is, oh, did I make a mistake? This is x plus 2, so that should have been 2x, positive 2x squared. Sorry about that. X squared times x is x cubed. X squared times 2x is 2x squared. So now I subtract this. I'll get negative 7x squared. And I bring down the rest, minus 9x plus 10. And I repeat the process. How many times does x go into negative 7x squared? That's minus 7x. I take this, I multiply it by that, and I put the result underneath. I'll get minus 7x squared minus 14x, and subtract the result. Minus 9x minus negative 14x is 5x, and bring down the 10. It's plus 10. X goes into 5x 5 times, so I multiply, write the result underneath. I get 5x plus 10, subtract, and I get 0. So just like I wanted, I find that the remainder is 0. So x plus 2 is a factor, which means that negative 2 is a root. So the fact that it's a factor, this part says we can write x cubed minus 5x squared minus 9x plus 10 as x plus 2 times something with no remainder. We figured out what that something is. It's x squared minus 7x plus 5. So the fact that there's no remainder means x plus 2 is a factor. And minus 2 being a root says that if we plug in negative 2, we should get 0. So if we do negative 2 cubed minus 5 times negative 2 squared minus 9 times negative 2 plus 10, this is going to be negative 8 minus 5 times 4 is 20 plus 18 plus 10. And if I've done everything correctly, this should be 0. So that is how we use all of these things to find zeros. The process is basically to do long division by a linear term, and if you get a remainder of 0, then that constant or the negative of the constant is a root. So I hope that this helps you to understand what's going on here and try the web work problems Please come to me if you have any questions. We'll be practicing this a lot in class. I'll see you soon.